Hello students. Next let us look at the proof of these two, that is the parallel connection and series connection. How do we get this as the answer? Let us look at the proof. The proof is very simple, it's not very complicated. So let us start with parallel connection. Now as you can see here, we have connected two port networks in parallel, and now I am going to write what is the current going to be. So let me use a different color. So here the voltage is plus minus V1, that is no issue. Here also the voltage is plus minus V1. And now the current that is coming here, let me name it as I1, and here let me name it as I2. See, this is Y dash, or this is the first two port network where I am representing everything with a dash on top. So the current that is entering here, it will be I1 dash, and the current entering in this one, in this stream, I will call it as I1 double dash. Why? Because it is entering the second two port network. Similarly, the current I2 that is entering here, I will name the current that comes here as I2 dash for the first one, and for the second one I will name it as I2 double dash. Now you can look here, the voltage V1 that is appearing in the across this first two port network is the same that is appearing here. I am not going to write V1 dash, V1 double dash. Why? Because the same voltage V1 is going to appear here, and the same voltage V1 is going to appear here. That is why it is basically the parallel connection. In parallel connection, the voltages across two parallel network elements are going to be the same. Same is the case here. Sorry, I should not have written V1 here. I should have written V2. Okay. So the same voltage V2 will appear here, and the same voltage V2 will appear here. So I will not write now V2 dash or V2 double dash, because they are all going to be the same. Now we know that for the first two port network, we know, so what I will do is I will additionally write this one with a different name, so that let me make the derivation in a proper way. So let me call this as N1, and this let me call it as N. So I'll call it as N1, or I'll call it as N dash, and the second one as N double dash, or I will let me call it as N2. Okay. So now I can say that for N1, the Y parameter is given by, what is the equation of Y parameter? It connects the current I, so it is going to be I1 dash and I2 dash is going to be equal to the Y parameter Y11 dash, Y12 dash, Y21 dash, Y22 dash. That multiplied with voltage V1. Now we will think that, okay, let us write it as V1 dash. No. Why? Because we have not named the voltage here as V1 dash. It is same as V1. Even if I write V1 dash is going to be same as V1. So I will name it as V1. Similarly here also I will name it as V2 and not V2 dash. Okay. Now this is for N1. Similarly I can write for N2. So I will write for N2 the Y parameter. For N2 the Y parameter is given by, now for the second one we know that the current equation is I1 double dash I2 double dash, and that is going to be equal to Y11 double dash, Y12 double dash, Y21 double dash, and Y22 double dash, that multiplied with V1 V2. Again, I am not writing V1 double dash or V2 double dash because the voltage that is appearing here is V1, and here also it is going to be V2 and not V2 double dash. Even if it is V2 double dash, if I write, that will be same as V2. Why? Because both the two port networks are connected in parallel. So now I have got this. So if I am going to look at the whole, if I am going to look at the totality, let me draw it using a different color. Okay. If I am going to take this whole thing as a single network, suppose if I am going to draw this whole as a single network, then it has two ports. One is having current I1 with voltage V1, and the output current is I2 with voltage V2. Therefore, I can say that I am going to write it as a single network. So if I am going to write it as a single network, what I can write is, if we imagine this as a single two port network with input V1 I1 and output V2 I2, then I can write what is the value in between and all. But now see, I1 is what? I1 is I1 dash plus I1 double dash. We know, and we know from figure that I1 is going to be I1 dash plus I1 double dash, and I2 is going to be I2 dash plus I2 double dash. So where is I1 dash and I2 dash? In this equation number 1, and this is going to be equation number 2 where I have I1 double dash. Therefore, I can say that I1, I2, if I want to find out, that will be basically adding up I1 dash, I2 dash plus I1 double dash, I2 double dash. Correct? Why? Because according to the figure, I1 is going to be I1 dash and I1 double dash. Therefore, from equation, so I will write from equation 1 and 2, I will get, this is basically what? 1 plus 2. So I can write, it is going to be y11 dash, y12 dash, y21 dash, y22 dash into v1 v2 plus y11 double dash, y12 double dash, y21 double dash, and y22 double dash into again v1 v2. From where I can see v1 v2 is common, therefore I can write I1 I2 is going to be equal to, if I take v1 v2 common, so let me write v1 v2 common, whatever is remaining are two matrices which are added to be together, isn't it? So I have to add them together. If I have to add them together, then individual elements are added. So I will write it as, it is going to be y11 dash plus y11 double dash is going to be y12 dash plus y12 double dash. This is going to be y21 dash plus y21 double dash, and this is y22 dash plus y22 double dash. And that is where we have got this result, that the y parameter is going to be the addition of the two parallel networks, and only y parameter. You cannot do this with z parameter. Most of the people think that okay, this can be done with z parameter, with x parameter. No, in case of parallel connection, only y parameter, no other way. Okay. Similarly, let us do, so this is hence proved. Okay. Next, let us do for the case of series parameter. Sorry, series. So now in this case, for the case of series interconnection, we are having voltage V1 that is appearing across this one. So in series connection, what do? We connect this with the bottom one. Similarly, this we connect with the bottom one. So now see, have a look here. If I am going to write the currents, so this is going to be the current I1 that is going to come out, go in, and here I1 will come out. Isn't it? That is what is two-port network. You have current going in and I1 current going out. Similarly, you have I2 current going in and you have I2 coming out. Now this I1 current itself will go inside this one. So here I should not write this as I1 dash for top and I1 double dash for the bottom. Why? Because both of them are same, and that's why I am going to write them as I1 itself, and here also it is going to be I1. Similarly, I2 that is coming out, it is going to go in like this. So this is also going to be I2 and not I2 double dash, and I1, I2 dash separately I will not write. In previous case, the voltage was the same across both. Here the current is going to be the same. So here it is I1 is going to come out also. Here I2 is going to come out also. Okay, so the current is same. Now I will not write it because I don't want to clutter it. Nothing, no other reason. You can write, but I will just avoid it for the time being, because what is important here to know is that you are having the same I1 current going in and coming out. Correct? Now, what about the voltage? The voltage that I am going to have, that is going to be different, because the voltage plus minus V1 that I am going to give here, that voltage V1 is going to be split up into plus minus V1 dash and plus minus V1 double dash. And similarly, the voltage that I am going to give here, which is V2, sorry, is going to be split up as V2 dash and V2 double dash. Clear? So now what I am having is, I am having the circuit which is connected in series. Now we know for N1, for N1, the Z parameter is given as, for N1 the Z parameter is given as, how do we write the Z parameter? We know it is voltage and current. So it is V1, V2, but here it is V1 dash and V2 dash. Why? Because the voltages are different. Multiplied with Z11 dash, Z12 dash, Z21 dash, Z22 dash. That multiplied with the current. Now the current I can write it as I1 dash, but there is no point because it is going to be the same. So I will write I1 and I2. That is what is the main thing here. You are having I1 and I2. Similarly, for N2, the Z parameter is given by, so for N2 if I am going to write, then it is going to be V1 double dash, V2 double dash is going to be equal to matrix Z11 double dash, Z12 double dash, Z21 double dash, Z22 double dash, multiplied with, again the current is going to be I1, I2. This is the same current that is flowing inside port 1. The same current is flowing inside port 2. Okay, so here the currents are common. So now if I am going to consider this as a total box, consider this whole thing as a total, this thing, then you are having V1 as input, V2 as output, correct? and the current I1 and I2 as the two currents. So if I'm going to consider that, then I can write for the combined network. For the combined network, for the combined network, for the combined network, see, for the combined network, what do we see? The voltage V1 is getting split up into V1 dash and V1 double dash. Similarly, V2 is getting split up into V2 dash and V2 double dash, correct? So I can write that V1 is going to be V1 dash plus V2, sorry, V1 double dash, and V2 is going to be equal to V2 dash and V2 double dash. That is, I have to add the equation 1 and 2 here. I have to add the equation 1 and 2 here. Therefore, V1, V2 I can get by adding V1 dash, V2 dash with V1 double dash and V2 double dash, which are equation number 1 and 2. So I will write them as Z11 dash, Z12 dash, Z21 dash and Z22 dash. Here I am going to take I1, I2 common, so I will write the other thing also. So it is going to be Z11 double dash, Z12 double dash, Z21 double dash and Z22 double dash. And this is multiplied with I1, I2, which I can now write it as is equal to Z11 dash plus Z11 double dash Z12 dash plus Z12 double dash Z21 dash plus Z21 double dash, and finally Z22 dash and Z22 double dash, that is multiplied with I1, I2. So that is going to be my V1, V2. And that's how we say that if we are having two networks connected in series, then we have to use the Z parameter and add both of them and get the combined Z parameter. So for series, you should remember, for series it is Z parameter, for parallel it is Y parameter. You should not mistake it. Okay. Now let us do a problem. Yesterday we had seen a problem for the parallel interconnection. Let us do a problem today for the series interconnection. Okay, so with this we are completing the proof of the parallel and series interconnection. I had also taught you cascade interconnection, but since that's not there in the syllabus, I will not use that to show the proof because it is unnecessary for you. See, other than this, we are having series parallel connection, parallel series connection and all. In the previous KTU syllabus that was there, but nowadays it is not there. So only parallel and series interconnection we are looking. So let us do a problem on series interconnect. Determine the Z parameter of the following network. So here we are having a network. Now this may look like a simple problem. This is the same problem that I had given for your third series examination, but now I am going to solve it using the interconnection method that we have just now studied. See, when you look at this, you can directly actually think like I am having two networks. One is this one, and let me write the transform value. So 1H is going to be S and the capacitor 1F is going to be 1 by S, correct? And this is going to be the second one, which is again I will write it as S. And the second network is like this. Suppose if I am going to write or I am going to draw the bottom network, this is going to be S and this is going to be capacitor is going to be 1 by S and this is going to be again 1 by s. So I am having two, I have split the above circuit into two parts. Let me draw this one as a two port network, and let me draw this one as another two port network. And if I am going to interconnect both of them in parallel, see, I have connected them. So what is there? I am having two connections. One I have connected like this, and I am having the second connection like this. Both of them can be actually drawn by a single connection in between, but that I have split up into two parts. And because of splitting up into two parts, I have got two circuits or two T networks which are connected in series. In series connection. Correct? Two interconnected networks, two T type of interconnected networks. Now, see, because of this, how simple the things are going to be. So now I am having here this, let me name this as two port network N1, and then this one, let me name it as N2. So solution is, for N1, the Z parameter is the Z parameter. What is going to be the Z parameter for a T network? Why do I call it as a T network? Because we know that for a T network which is having a shape like this, the Z parameter is, if suppose this is Z1, Z2, Z3, we know that the Z parameter is given by Z1 plus Z2, Z2 plus Z3, and here it is going to be Z2, Z2, correct? That same concept we are going to use for this N1 network. So for N1, the Z parameter is going to be given by, so I will write this as Z dash, because it is for the first network, isn't it? So it is S plus 1 by S. Similarly, here it is also going to be S plus 1 by S. Why S plus 1 by S? This plus this. And similarly, this plus this. And then corner ones are going to be the one in between, which is 1 by S. And this is also going to be 1 by S, which I can actually write it as S square plus 1 by S. This is going to be 1 by S. This is going to be 1 by S. This is going to be S square plus 1 by S. Correct? Similarly, for N2 network, which is also a T network, but it is shaped upside down. For N2, so the T network is now inverted, and there is no issue if you are having inverted. The value will be, suppose this is Z1, this is Z2, this is Z3, then for it again it's going to be Z1 plus Z2, Z2 plus Z3, and this is going to be Z2 and Z2. The same concept. So for N2 also I will write the Z parameter, which now, since it is the second one, I'll write it as Z1 double dash. It's going to be 1 by S plus S, 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 1 by S plus S, which comes out to be, which I can write it as the double dash is equal to S square plus 1 divided by S, 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 S square plus 1 divided by S. And now I can say that from figure, N1 is connected in series with N2, is connected in series with N2, and that which is connected in, so therefore I can, therefore for combined circuit, for combined network or circuit, Z parameter is going to be Z dash plus Z double dash, from which, if I am going to, therefore Z is going to be equal to, now I have to add individual elements. The individual elements is, if I am going to add them, it is going to be S square plus 1 by S plus S square plus 1 by S This is 1 by s plus s. This is going to be 1 by s plus s, and this is again going to be s square plus 1 by s plus s square plus 1 by s, from where I will get s square gets added. So 2s square plus 2 divided by s. Here also it is going to be 2s square plus 2 divided by s. And in these corners it is going to be s square plus 1 by s and s square plus 1 by s. And that is going to be our combined z parameter for the network. Now, if suppose they would have asked you to find out h parameter, what is the shortcut? Or how can you do it? First, find out the z parameter by this method, then use the concept that we have used for interconnection, or sorry, the interrelationship. So, if you have got the z parameter, using z parameter, you can find out the h parameter. So, always remember that two-port networks is not very difficult. If you use the shortcuts correctly for any complex circuit, you can find out the answers using these three pointers that we have studied. That is, what is a T network, what is a pi network, how to interchange between z parameter, y parameter, h parameter, a b c d parameter, and now finally based on the interconnection. Thank you.